Hello everyone, a very good morning again. I'm Leong from Wizlogix, the host for today's WizConnect webinar. Wizlogix is the Singapore IPC Authorized Training Center in partnership with Black Fox Training Institute from the US and SHRDC from Malaysia to offer a series of IPC certification programs in the Southeast Asia region. Mr. Leong is our guest speaker today. He's the Master IPC Trainer of Black Fox Training Institute, MIT, who is certified to train CIT, CSE, and CIS in 3 IPC standards. They are the IPC 600, that's about acceptability of printed boards. The second one is the IPC 610, that's about acceptability of electronic assemblies. And the third one is IPC 620, which covers the requirements and acceptance for cable and wire harness assemblies. You might have a clue already which IPC standard he's going to touch on in the next 1 hour. Without further ado, let me pass the time to Wayne to start with his sharing on the topic, Attain seamless connection in cable and wire harness assemblies with you. Wayne, please.
Yeah, good morning, everybody. Welcome to this webinar. And hopefully that through this webinar, you all can actually learn something new and will be interested in the program. Okay, today what we are talking about is more or less actually is to attain a seamless connection in cable and wire harness assemblies, right? Saying actually is very simple, to achieve a seamless connection. But in what means and what way can we do about achieving that? So frankly, in a way is that a lot of our people will say that, oh, just actually strip the wire, right? Connect it and to the terminal and that's it. But it's actually not that simple, okay? So first actually under this IPC 620, right, you actually have some actually means and methods of connection on this one. So actually they describe actually the types of materials used, the methods, all the tests actually that are being involved. And actually on the acceptability criteria, how are these material tests and methods to be acceptable condition? Right, in order actually to produce a very good crimp, right, or mechanical secure or solder connections. Because actually, as you know that from wire to terminals and all those type, how are we going to connect them? You actually got many methods of doing it, right? You actually can crimp the wire to a terminal, crimp, and after that, then you connect to the receptacle to make a successful connection. And important actually is that what type of crimp is acceptable and what type of mechanical strength it must produce, and then actually to give a very good, effective connection of it, right? And actually on to the here also is that they also actually important is that how we do it is that it must actually based on the process control, right? You cannot just say that, oh, I just use a person who just strip the wire using the visual, right? And then in a way is that there won't be any consistency in that. So a lot of things actually we come to is that important is that how do we pull up into our process so that the quality will be consistent and everything will be successful. Okay. So over here actually the first thing actually we need to know is that like in like PCB and printed circuit board assemblies, all those type, wire harnessing also classified into 3 classes also. But bottom line is that who are the one who determine what class they're going to be used. So definitely will be the customer, because customer is the one who pay for the amounts on the product to be produced, right? If the customer wants a product, we just only produce a function and won't give you any reliability, they actually will pay a low price, and definitely that will go to class 1. Where the main thing actually is that after the assembly, it definitely will work, but it will not give you the reliability. And then next actually comes to it is that it's the data service electronic products, where these are definitely you pay a higher price, right? This is under class 2. Like example for those laptops and all the stuff. So when it comes to the nature of this one give you a more reliable product and it can last you actually easily for years, right? Next come to the highest one will be the class 3 product, which is the highest performance under harsh environment and all this sort of condition. The product will never fail, right? Just in the way is that what are all these in details, we're going further to that, right? So let's say we go into the class 1 product, right? Where you only classify as just a function, right? Example, like it's got a electrical can opener, right? Watch, electronic watch, right? All this actually comes in, the product will not cost you much money. Easily less than $100, you can achieve it, okay? Next example will be class 2, where this one give you a certain reliabilities, and then in a way that you would definitely last for years, right? Example, that actually is a high-tech TV, right? And some laptops, and even though a photocopier. So all this product comes in, definitely when you pay for it, you will not expect it just to last for a few weeks or a few months and then it break down. Definitely it lasts for years and as it goes on. And definitely the price you're paying thousands of dollars over that, okay? The next one actually will be the highest class, will be the class 3 products, where this one actually, the product is, you must perform no matter what condition this is, right? And in the way is that you have to, is the product fail, things actually, unhappiness will comes in, like injuries, and even though the worst condition, death. Right, example, in a plane, right? Who would want to actually sit the plane, then halfway, it break down. And when the plane goes, it's not like transformer, you transform the robot and then it stand on the floor already, right? Definitely you'll crash already down. And when it crash, what happen? Life will be affected. Okay, so these actually are the 3 classes that you'll be talking about during the training. So one of the few methods you can think of is by heat stripping, right? When you use a heat remove insulation, and then actually make a cutting to remove that. So during actually the cutting, affecting to it. And in a way down here, you can see that under this table, right? You got different strands of wire that coming to it. The first row, you can see that a solid conductor. Some will say, oh, solid conductor doesn't matter, right? But you also have a gauge of how the damage it can be is under the acceptable condition. So when actually you strip the insulation, right, the conductor will be compressed. And in a way is that if you do not compress more than 10%, it still be acceptable, right? And as you go on, the number of strands that comes in, the different condition, you also have it, right? Example, 16 to 25 strands, right? For class 1 and class 2, you can see that allowable maximum damage is only 3 strands, right? But if you go to a class 3, when they use for crimping. So in a way, is that when this is a wire where they do not thin it with solder, right? It's actually 0 damage. And when those actually allowed to go for apply a coating of solder over that, and that actually allow a maximum of 2 strands. So you can see the difference in that. Okay. So next one, they come into and see that what normally people ask, what type of damage you are talking about, right? In a way, is that neck, severe, or whatever is that. Here is 2 pictures over here. On the left, you can see that this picture over here, this 4 strands of conductor has been severed. So once actually is severed, is being cut off, right? And in a way, is that the cross-sectional area of the conductor is being affected. So ending out, you can see that the conductor amount actually depending on what it actually is to transmit the power across to the from the terminal to the source there, right, to the destination where actually they transmit the power and voltage and current. And when actually the conductor strength actually is severed, what happened? The cross-sectional area will be reduced, right? As you know that in the electrical part of it, right, if the cross-sectional area is reduced, resistance will go up. So in normal, actually is that if the wire works in a normal condition, right, which is just to the most is just a lukewarm, it still be okay. But if actually the cross-sectional area reduce and resistance build up, it become hot. As you know that wire are covered by insulation. So once it become hot, prolonged goes on, what happens? The insulation will soften and slowly you give way, and then it actually will be, disaster will happen, right? As you can see over there. So next, actually, you can see that over here, this is just a nick where actually this slide then onto the strength of conductor. So when you come to the nature of this one, you also follow the 10% rules, right? As long as it's not more than 10%, it still be okay. But once it's more than 10%, that definitely become a damaged conductor strength. This is talking about crimp terminations, right? Where actually either is onto the contacts or onto the cable line. So a critical element actually under this one is that, right, the connection between the wire and the terminal is crucial. And actually, we're using different methods of doing it. Crimping actually is one method of doing the connection. The other connections actually is by routing onto the terminal, by soldering, right? And also by splicing also, they do have that. So now this one actually we talk about is more of a crimping. So crimping actually is one method that make this connection. And in a way is that how to determine a good termination. Actually, the important is that you must ensure the mechanical integrity. So that when the wire actually is being crimped onto the crimp, right? You actually will have the holding force, right, to insert onto the receptacle, right? In a way, when you insert in, you need to remove the connection at times also. So when it comes to remove, if the mechanical strength don't give that, when you pull out the time, the wire will come out, but the crimp is still stay in there. So good termination, you must ensure that you have to have a good mechanical integrity. So you hold the wire in place and then give a good conductivity. Next, actually, you also need to meet the electrical requirements also. Because actually, what is important is that after crimping, you need to transmit the power across, right? If actually you don't meet the electrical requirements, what happen, right? You have intermittent problem, and then your connection will not be strong, right? Ending up, you have a issue of having breakdowns, and then didn't have a good connection to transfer your power across, right? Next, actually, you come to talk about also about the basic requirements, right? A lot of us say that, oh, quite simple, and that when it comes to crimping and stuff, I just actually strip the wire and then crimp into it. So in order actually to give a good connectivity and good connection, what is most important? First thing is that you need to go into the basic is that no damage must be happen to the plating or the finish, because actually you can see that some wires are plated, right? Some wires are not. So in a way is that if the plating and finish is damaged, what happens? The wire actually will be affected also. As you can see that under this crimping termination, what is important? The crimp itself, it comes in order to prolong connections to it. What is important is that it have to be plated so that the conductivity will keep on the work and then to transmit the power across. So during the crimp, if the plating is damaged, what happens? Copper will be exposed. And from the nature of this one, you can see that once copper is exposed, through time you oxidize, and ending up the conductivity will be affected, right? Then next come to it, you can see that it's important is that when you strip off the wire, right? The actually terminal, actually the strands of conductor inside that, you also must stay intact, right? And not to be deformed. And once it's deformed, or then they form in the bird cage like that, you can see the picture on the left, right? That actually will affect the function. Next actually is that the conductors also shall not be cut also. As I mentioned earlier, right? It must actually maintain the cross-sectional area, which actually in the technical terms under IPC is a circular mill area. So once the circular mill area or the cross-sectional area is affected, the function definitely will be affected, right? And at times it comes in, the design also plays a very important role, is that they would not choose the wrong terminal to the wrong wire, right? And in the way down here, you can mention that, right, contacts shall not be altered, right? You cannot change the contact to accept an oversized wire, because in the way is that when wire actually a bigger wire, and the contact actually the hole there is too small for it to admit in, you cannot drill the hole bigger, because actually the contacts are designed to have a mechanical strength. Once you drill the hole, the wall is thinner, the strength definitely be weakened. Okay. Next, actually, you can see that these actually are different types of contacts and lugs actually go into it. You can see on the left side, you got the cable lug, and the way of actually how this connection is being accessed, right? And the center one you can see here, this is actually the machine contacts, right? And how to achieve that, to get a good clearance, to get a good contact, and then to make sure that the conductor did really go into the contact to give a positive connection. On the right side will be on another type of cable access. In the training, actually all these various conditions will be assessed. So this actually next we talk about more or less is on the terminal side. We got different types of terminals. We got bifurcated, as you can see on the right side here. These are bifurcated, where actually they got two poles over here. And the wire are being connected to this one. And then next they come to actually is a the center, this one is a turret terminal, and then after that actually is a slotted terminal. So slotted terminal, all these when they connect, they also have a very important role in the placement and the connection. So you can see that how the wire are being actually placed onto it, right? After you place, definitely solder will be added to it to close up the connection. Right? You won't be just placing like that. Nobody can give assurance that, oh, I put wire like that, it can start to work already. Definitely not the way. Okay. So in a way, it's actually that the topic also talking about like sleeving and boots, right? And the position of how it's being, right? When you connect actually wires to a connector, right? And actually after that, we also need to protect the terminal from exposed and from short. So actually, they actually will put a sleeving boots onto it, right? And all this actually comes in, they also got a condition of how it should be. And when it comes to the normal factory application, they got two types of sleeving and boots, right? One actually they have adhesive 9 into that, right? And the other type actually is a non-adhesive, right? Adhesive actually is that they actually is a little bit loose, so actually they'll just fit into that and apply adhesive to hold the sleeving onto the connector. The other type actually is more of a string tube type, right? Where actually that it actually is more of a pressure ring. Actually, you just actually slot onto the terminal, the connector there, and then actually you hold it in place. So this type they won't use adhesive. Okay. So you can see that under this side of even got round and even they got rectangular type of connectors, right? All these conditions when they connect that time, right? We cannot assure that you always be perfect. So what are the tolerance that is being allowed to it, right? You can see that over here, they also guide you on the amount of adhesive to put on and also the alignment of the connector to it, right? So you can see that under this is the condition, these are the things being mentioned also, okay? Important actually is that these are the few things actually we'll actually just discuss over here. But are these the only things that we'll learn on that? No, sorry, it's not the only thing. Definitely more things will be that. And if it's that little things, then the training wouldn't be that meaningful enough. So in a way, it's that how to attain a seamless connection. There are actually more criteria actually to be looked into also, right? Example that when comes the crimping actually is the one that we have mentioned. They also have those insulation displacement, where actually they do not strip the wire. Normally on this type of condition, the wire used actually is a flat cable. They actually will be mounted directly onto a connector. And once actually they crimp on, this one will give the connection. They're also talking about solder terminations, right? And also high voltage application. When actually to use a normal solder connection, when actually to put onto the high voltage. Definitely the solder condition is totally different. We cannot use a normal solder termination for high voltage. Because when it comes to high voltage, all these are high power, any straight edge, any icicles, any sharp points, all this will cause arcing and actually more danger will comes in when that happens, okay? So we also talk into the nature of a connectorization, where actually all the connectors, how are they being mounted on and the condition of the acceptance condition. Whether how to assess that whether this connector is still be able to use properly or in a way actually it's time to change a new connector. So they're also talking about overmolding and then potting. Because actually these are the two where the terminals are being hidden into the plastic parts, right? Plastic mold over there. So when it comes to it, when to use overmolding and when to use potting. Right? So we also talk into the nature of marking. Marking actually create the identification onto the wire, right? Definitely these are crucial also. How we mark it and enable it so that when we do the connection, we know which wire connect to which wire, right? Not in the way that if they are not marked, it's actually a very high risk and actually might cause death also, right? When we connect earth to our life, right? Ending up the whole thing will be under a live condition and anybody will touch it with the electrocuted, right? So next actually also talking about the shielding, right? And then the protection on the wire itself. How wires, when it comes to certain condition, where actually they are on moving parts and all those type. So how do we protect the wires? Right? And also on the finished assembly installation, how the wires being routed and how being joined to that. And in the training also, they talk about splices and ultrasonic welding also. So when they actually we use splices, right, more or less actually these are more for repairs and all that. And when do we use ultrasonic welding, right? Also actually talking about on the coaxial condition, right? Coaxial and biaxial cable assemblies. What are the things that we need to look into? Okay, so this one it'll be the end of the webinar. You all just go back and then review, and then to see how they. So Leona, I pass it back to you.
Thank you once again, Wayne, and thank you for all of your attending. Right, if you don't have enough and would like to understand more of the requirements and acceptance for cable and wire harness assemblies, do consider joining our full certification course in IPC CIT, CSE, and CIS. All right, thank you so much for watching and hope you enjoy the session. Have a nice day ahead. Goodbye.